Now I will give you some thoughts about the contemporary situation on planet Earth and how, with the new knowledge, we may live our lives without destroying for future generations. Are you ready? Yes. So the setup for these 30 minutes, for 30 years of research in 30 minutes. First, who am I? Then some words about Earth system science. And then the sensitivity of the planetary systems. And we end up about pandemics versus planetary and human health. So who am I? This is me, 28 years old, in Antarctica. I was a glaciologist by then. I'm a trained geographer and have a PhD background in Earth system science and glaciology and climate development. I've studied from Lund University and then continued in Stockholm, because Stockholm is specialized in glaciology and climate development. And then I worked for an international network with 12,000 researchers called International Years for Biosphere Program, that is Earth System Science. For a couple of years, I was head of media for the Royal Swedish Academy of Sciences with the Nobel Prizes in physics and chemistry and the economic prizes. Then I went to the industry, working with commercial freedom of speech, as they call it, just to learn how H&M, Volvo, and IKEA, how they work. I started with some other friends, the Protect Our Winters in Sweden, which mobilizes the ski community in the climate issue, because as a skier, we are dependent on snow, stable climate. That's our passions. As well with Plogga, that's an organization working with you while you jog in the nature, you pick trash. And it has spread around the world in over 80 countries right now. And I also work with politics it's a green think tank. Not party politics, but know how the politics work. And since 4 years, I run my company called Sustainability. It's a word game, as you understand. And as my scientific advisory board, I have Berlin Center for Climate Research, Stockholm University. So this is northern Lapland in Sweden, the Tarfala Valley. There's a Tarfala research station far down to the left. If you look around here, that's the Tarfala research station. This is on 1,100 meters above sea level. And you can see that was the summit of Sweden, Kebnekaise South Summit. But since 1 year, it's the top glacier, and it has melted so much. So now the second highest point is higher. So we lost our highest summit in Sweden because of global change, or climate change. This is quite symbolic. But if you go up there, I can recommend, it's a fairly easy climb. You can see 11% of whole Sweden from the summit. So I can recommend to go there. So Earth system science, what is that? Well, we have, it's about when you integrate all the natural sciences with the human sciences in time and space, in atmosphere, ocean, and land, then you see the system perspective. And that's where you can draw conclusions that are far more in the future than if you just work in one science. We have, it's called the Great Acceleration. Let's see. Yeah. The Great Acceleration, it's happened around the 1950s. And they have quantified all this science in some charts. And you're not supposed to see the charts exactly, but the x-axis is from 1750 until today. And this is the world population, how it increased. And after 2 world wars, everything stabilized. We started to consume, to buy cars, and to travel, and the population rose rapidly. You can see our GDP, gross domestic product, increased a lot, and a lot of activities in humans started to increase. Transportation and telecommunications was later, but international tourism, nobody took a tourist trip before 1950. We were farmers mostly. So how has the Earth system reacted on that? You can see the same period after the great acceleration, the carbon dioxide increased a lot, nitrous dioxide, methane, and you see a lot of systems that have reacted pretty heavily, and tropical forest loss. You see, that's incredible, and that's the lungs of the Earth, as you might know. So we have not been nice to the Earth, the humans. To quantify this more, we have a thing called 9 planetary boundaries. There are some researchers, a Swedish researcher called Johan Rockström, and an Australian researcher called Will Stephan, and I worked with them both. They've developed the 9 planetary boundaries to create a safe operating space for humanity. In this, you can see, climate change, you have ocean acidification, and biogeochemical flows from the agriculture, for instance. And if we stay within the blue circle, that's safe for us humans. If we pass the red one, it's kind of irreversible in many ways. So you can see biosphere integrity, the biodiversity, we're in the loop of a mass extinction. And also there's too much phosphorus and nitrogen out in the oceans because of the agriculture. The climate change has actually reached, so we are just on the border of a tipping point where it can self-enhance itself. So it's about, we have a planetary urgency in many ways. One of the examples is if we look at the forest, for instance. A natural forest with high biodiversity absorbs twice as much carbon dioxide as a tree plantation or a monoculture or a tree field. This is what you normally don't hear from the forest industry, because they earn a lot of money for planting trees, cutting them down and sell, because it makes money. You must note that this image does not show a forest. A forest with a healthy ecosystem takes at least 100 years to create. And in the tropics, it takes up to 1,000 years to create. So if we cut it down, it hasn't even been a forest yet. It's a tree plantation. So the sensitivity of the planetary systems. We have a little detail that happened just on the other side of the Atlantic, or it's happening right now. The day after the election, the 4th of November, the greatest emitter of carbon dioxide per capita on planet, they left the Paris Agreement. The first successful agreement to combat climate change, and the most important actor decided to leave. Let's all hope that this that the serious climate business can have a restart in 20th of January in 2021. Hopefully, but with that maniac on the other side of the planet, we're not sure. So, how do we manage and respect the biotopes that create the conditions for life on Earth? Let's have a look at the global carbon budget for the Earth. So we emit around 41 billion tons of carbon dioxide each year. Most of it, 35 gigaton, comes from fossil fuel and industry. And about 6 gigatons comes from the land use, land change. But luckily, the terrestrial ecosystems, they take up 12 gigaton, and 9 gigatons in the oceans because of all the algae. But the net positive is 20 gigatons added to the atmosphere. So nature can take care of half of our emissions, but the rest stays in the atmosphere, heating up the atmosphere and all the ecosystems. So why do we talk about carbon dioxide? There are so many other greenhouse gases, right? But we look at carbon dioxide, the lifetime of carbon dioxide. We emit all those 41 billion tons each year. After 100 years, 75% remains. And after 1,000 years, still 40% remains. And after 10,000 years, when we're supposed to go into the next ice age, still 25% remains. So it's a super potent greenhouse gas. That's why it's so important. So in my area, within glaciology, we drilled an ice core that came back 8 ice ages back in time. So this shows the heartbeat of Mother Earth, the temperature, and the carbon dioxide level. And you can see, the ice ages, they are ruled by this Milankovitch cycles. It's the relation between Earth and Sun. It's 3 different cycles. But on top of this, the greenhouse gases are forcing or decreasing this heating effect on Earth. So we've been, if you look here, between 180 and 300 parts per million for over 3 million years. When we actually left, we were still monkeys, humans. But now, this spring, we were up to 480 parts per million. That's 50% higher. And that equals 3 degrees warmer than pre-industrial temperature. And that is Earth that cannot inhabit very many people. So it's a dangerous path we're walking. So if we look at our relationship with Mother, you can see that all this is the emissions of carbon dioxide. And every time we have a crisis like oil crisis, the fall of the Soviet Union, or now the financial crisis, or even the corona crisis, then the planet and the climate recovers. But as soon as the economy recovers, then the emissions starts rising again. And that's a bad relationship. We should go in therapy with our Mother. And to reach our maximum 1.5 degree warming, we must reduce our emissions by 50% for each decade until 2050. That is what we have ahead of us. During the corona crisis, we believe that the emissions will be reduced by 7 to 8%. And to meet the Paris Agreement, we need to globally reduce emissions with a corona crisis every year until 2050. And we call it the super crisis. But this is actually what we have to do. The question is, can we do it? So if we look at the carbon dioxide levels, a lot of people ask, well, now we decrease the levels, it's getting colder. The answer is no. Why? Because you can look at the atmosphere as a bathtub being filled rapidly. So if we reduce the increase with a few percent, the level is still rising. Like, you just turn down the water a few percent, it's still flowing. Only a little slower. So we have a question we must ask ourselves. Our planet is home for at least 10 million species. The majority in the tropical rainforest, which is the biotope with the highest biodiversity on the planet, where many substances in our medicines are found, for instance. And this biotope balances the oxygen content of our Earth. So, but in our environment, it's characterized by humans only one species dominate. The question we must ask ourselves is whether the planet can handle both these types of systems. Is it possible? So we have, within Earth system science, we have found at least 15 tipping points around the world. The yellow ones are happening right now. We're looking at the West Antarctic ice sheet starting to melt, the Thwaites Glacier. It's melting 10 times faster than 50 years ago. The Greenland ice sheet, we know it will disappear. It's just a matter of time. Arctic summer ice is disappearing. Alpine glacier lost 50% of their ice in 70 years. And the coral reefs, half of them are dead today. And that's the kind of kindergarten for fish in the oceans. And we also have a thing called teleconnection between the Amazon rainforest, the biggest rainforest, the biggest biotope on planet. It has the dynamics in Amazon. It rules the Indian summer monsoon. So the planet is not very big. So this is a complicated graph, but I'll try to explain it for you. We talk about planetary resilience, and resilience is the ability to recover after a disturbance. It illustrates how the change in sensitivity of the planetary systems in time and space. So the Holocene, if you look further away in the picture, after the Ice Age, it was a very stable period, but we have stressed every single natural system to the breaking point. And when the natural systems do not manage to buffer our disturbances, our previously stable system are no longer in balance. So we have left the stable system into a very insecure path. And we risk ending up in a planetary threshold. If all these 15 thresholds are passed, we go into a state called hothouse Earth. And that's where the temperature accelerates. And this planet can only host maximum 1 billion or maybe just 500 million persons. And we are heading to 10 billion. So if we continue like this, 95% of the persons of the Earth cannot have food or a safe operating space. What we do not know is how fast we get to this point. So we have to get back on track. That is the fact. So if we look at this pandemic, what's happening right now over the whole Earth, how it affects the human health. We have a view of Mexico City, wonderful city, but it's one of the world's most polluted cities. It has smog every day. Someone sent me this picture. We say that there's no way we can shut down everything in order to lower emissions, to slow climate change and protect the environment. Then Mother says to us, here's a virus, practice. So maybe the corona crisis is actually a rehearsal of what is just ahead of us. We are having a battle, but we have no idea what's coming after that. I like humor in this stressed time. So the effect on the corona pandemic to our health, and this is updated numbers today from the what is it called? Yeah, the world facts. 51 million infected today, 1.3 million dead. That is devastating. 31 million recovered. So that is about 3,400 dead per day since 1 year. The outbreak was 1 year ago about. So the effect on the corona pandemic on the world economy. So far, the gross domestic product globally is up by only 2.4% instead of 3%, which is normal. In the worst case, growth can be only plus 1.5%, but they still increase. And this leads to panic. I've counted on this. If the gross domestic product would fall to catastrophic 25% lower than today, it would correspond to the economic situation around year 2000. We didn't have a welfare crisis at year 2000. We're having a good living. So we have become accustomed to such a rapid, constant growth at the expense of the planet and believe that this is a measure of success. So it was, I saw a tweet from a financial economist from China, and he's from China and United States. He wrote like this: "It's funny how the economy is about to collapse because people are only buying what they need." It's pretty funny, right? And that's economists saying this. So now let's have a look at the economy's effect on our health when we do not have a virus pandemic. This is the largest study ever made in the Lancet, 60 groups of researchers all around the world. 9 million deaths from air pollution every year. And the most sensitive ones are kids below 5 years old and elderly above 70 who have a shorter life because of this. 2 million of these are directly linked to consumption. In Europe, 800,000 deaths each year linked to air pollution, and 30,000 deaths are directly linked to exhaust fumes from car traffic. So globally, 25,000 die every day due to air pollution. That's 8 times more than from the COVID-19. What should we be most afraid of? The abnormal economy or the coronavirus? It's just a question. So let's have a look at the impact of the carbon dioxide emissions from the coronavirus from January until the summer. In the beginning of April, the daily emissions of fossil fuels were around 17% lower than in 2019, which is the largest reduction of emissions since the World War II. And this is great. But as soon as the economy recovered, mid-June, the countries began to open up, and the emissions have sailed up just below 5% below normal, below the average of 2019. And today the emissions are basically restored. And the emissions in China, which account for a quarter of the world's carbon dioxide emissions, they have, if you look at them, they had a 25% reduction in February, but then they opened up the country and now they emit 5% more than 2019 because of the economic recovery. Is that a fantastic success? That's the question. So we look at the causes of deaths in China during the peak of the crisis. We can see that COVID-19 was on place 49 of the cause of death in China during the peak of the pandemic. And the 6 most important reasons are related to air pollution, even during the pandemic. In Italy, which were severely hit here in Europe, it was the 8th cause of death. And still the most crucial reasons for death was linked to air pollution. So to sum up, what creates and intensifies pandemics and zoonosis? This is a picture from Indonesia, where they are planting palm plantation from palm oil. Displacement of natural habitats by roads, cities, and infrastructure stresses the animals, so we get more in contact with the viruses. Urbanization and dense housing of people, and deforestation in all areas both boreal areas and tropical areas. And wildlife trade, what is very common in Asia. Fast global transport like aviation spreads the virus very, very efficiently. And lastly, air pollution makes us significantly more susceptible to viruses. They've shown that 15% of all the deaths, like 800,000, are strictly connected to air pollution. So it's two bad things happening at the same time. So as a natural scientist, I wonder, how should we see nature? Maybe like this. The deer is not crossing the road is actually crossing the forest. So what may we learn from COVID-19? An unsustainable lifestyle gives us a limited future. But if we change the letter U 2 steps ahead, sustainable lifestyle, unlimited future, what should we choose? So this is from Torres del Paine in Patagonia in southern Argentina. My question to you, my dear audience, is how can we build better conditions for people and nature? Thank you for your attention, and I'd love to meet you physically, but that will be another day. Thank you.